Well, look who it is. It's a geometry student ready to learn about areas of triangles and quadrilaterals. That'd be you. Yes, I'm talking to you. And you can find this lesson on these pages, 372 to 380. No new vocabulary here. It's some stuff we've learned already and some new formulas as well. But we're going to check out the area formulas for triangles and quadrilaterals. And let's get right into it. Don't forget to use your book to see some extra examples. And so first of all, let's just put down what all our different shapes are that we're going to be able to find the area of. So a square, they call this postulate 22. I won't ask you to tell me that sort of thing later, but let's just write that down for now so we can know what they might refer to as later. So that's a rectangle. We're going to put that right here. This is theorem 620, 6.20. Parallelogram. There's an area formula for that. There's an app for that, yes. Okay, theorem 6.21. A triangle. We've learned about triangles before, so a little review of that. Theorem 622. A trapezoid. There's a formula for that too. Okay, theorem 623. An isosceles trapezoid is just a type of trapezoid, so we have the same formula for that. A kite has a different formula. That is theorem 624. And finally, a rhombus. That's theorem 625, 6.25. So what are all the formulas for these? We'll draw these, or I'll draw these freehand. What's a square look like again? A square is, that's not my best square in the world that I've ever drawn, but hey, we're going to go with it. 4 90-degree angles. Trust what I draw in the picture. Those sides are all the same. If you called this S, this would also be S. The book refers to it like that. And then capital A in the context of this lesson is definitely going to be standing for, unless there's a point labeled with an A, it's going to stand for area. So capital A, it's just side times side. You've learned that before, so that should be a review formula. So area is side squared. Let's circle that too so that it stands out. So the area formulas we will circle as we go along. Rectangle, you should know this one already as well. But we have 4 90-degree angles. You could call it base and height or length and width. The book has it like this, so I'm going to use it like that. So the area is base times height. That should be reviewed from before as well. You could say area is length times width if they used L and W instead. Now a parallelogram gets a little more tricky, but I want to show you a clever way to remember this one. It seems a little more tricky at first. But you have the perpendicular height, and you would say that the sides here are parallel, the sides here are parallel. That's what makes a parallelogram a parallelogram. That's what defines a parallelogram. Two pairs of opposite parallel sides. The area here is actually going to be, if this is your height and this is your base. Notice the height is perpendicular. It's straight up and down. When you measure yourself with a tape measure or something like that, you don't measure yourself on a slant. Shapes don't like it either if you measure them on a slant. They like to be measured straight up and down. So how tall is this parallelogram? That's the height right there, going straight up and down, perpendicular. It's actually the same exact formula as a rectangle. Now why is that, you might say? What I'm about to draw here, do not draw this. Don't draw this. Don't draw this next. But I'll put this in green. If you took this triangle and cut it out, you got rid of it and you put it right over here, what kind of shape would you have outlining right there? That would be a rectangle. And guess what? You'd have base here times height here. That's why this works out. That's why it's the same thing. I'm going to get rid of all the green though, so you shouldn't have that stuff drawn in there. But if that helps you, you could make a note off to the side. If you found that helpful, please feel encouraged to add things to the notes. You're always encouraged to add things to the notes, but at least have what's here. A triangle. There's different ways the triangle might be showing up, but again, the triangle, it likes to be measured straight up and down, perpendicular. So if you had a triangle, don't draw this off to the side. I'll get rid of this in a second. Your triangle could look like that, or it could look like this even, but it wants to be measured straight up and down. So if that were the case, perpendicular here. But we're just saying in general, any triangle, talk about the base and the height. The base is going to be all the way from here to here. The height is going to be perpendicular to that base. This would be my h in that case. Let me bring these back. Don't draw these again, but this is just to help you see. That would be my base and height. Something like that. With something like this one, my base would be just from here to here. I would think about extending that out though for the perpendicular height, and that would be my height right there. And so this stuff, you don't have to draw that stuff. I'll leave that there for now though. If you want to draw that as well next to the triangle, that's okay. But what's the area of any triangle going to be? You can take that and make a rectangle if you double it. And you could do the same thing here. If you kind of double this, it would make a parallelogram. In a parallelogram, you can move the triangle over here and make a rectangle. So you could take this, same sort of thing. We could make another triangle and make a rectangle out of that. So it's half of a rectangle, 1/2 base times height. Now, trapezoid could look something like this. One possible way to draw that. Again, they want to be measured straight up and down, and so we would want to find the height like that. But this time it's base 1 and base 2. These are going to be different. This would be parallel to this. But if you were to think of it like this, don't draw this in. I'll erase this in a second. This is just to help you understand why it is what it is. If you were to take this and go kind of halfway in between there, and take this and go halfway in between there, and you were to take this triangle right here and put it in right there, and that triangle in and put it in right there, you would have this rectangle right here. And the rectangle would be the length of the base. The height would still be the same, but the length of the base would be the average of these two bases. It would be halfway in between this one and this one. That's how long the length of something like that would be, from there to there. So this one becomes, I'm going to erase that stuff now, but go back, rewind that, and re-listen to that if that helps. That really should help you understand not just that the area formula is a certain thing, but why it is that certain thing. Got lots of things to erase here. Just a second. There we go. All right. So why is this formula? Based on what we just said there, this has to be it. It's the average of the bases. So the average of the bases is 1/2 times b1 plus b2. Also that times the height. And so we have, this is another way to write that. The average of the bases times the height. So b1 and b2 are bases. And let's write this down too. It's the average. I'm running out of room here, but average of the bases times the height. That's another way to think of it. So that all goes with that here. A kite now. A kite would look something like this. This is an example of a kite. And then let's draw in the diagonals as well on this one. So that would be one diagonal, that would be another diagonal. Kite, this is what makes a kite a kite. You got two consecutive pairs of congruent sides. And this would be, we're going to call it D1. It's the length of one of the diagonals. This is going to be D2, the length of the second diagonal. And the kite formula is actually pretty straightforward. Hopefully you notice some triangles here. And so this is based on the fact that there's 4 triangles in here, and you could make a big rectangle if you just did D1 times D2. Let's show that here quick. Don't draw this. This is just to help you understand why it is. But you can duplicate each one of these triangles. Right here is the same as this. Right here is the same as this. Here is the same as this one. Here is the same as this one. So that duplication would give you the area of the whole red part would be D1 times D2. So the area of the kite would just be half of that, because each one of these triangles is half of the whole miniature rectangles here. So let's erase that though. So that's just to help you understand why this is the formula. Why this, let's circle that over here. I forgot to do that earlier. That's the big part to remember here. But y it actually is 1/2 d1 times d2. That's the formula right there. And so d1 and d2 are the diagonals, the lengths of the diagonals, but they're the diagonals. And then you can do the same sort of thing actually with a rhombus. So a rhombus, this is the same here and here. You draw in the diagonals. They're probably going to be different lengths. Unless it's a square, then they would be the same. Square is just a special type of rhombus. But we already have a formula for the square. So any rhombus, it works like this. Same sort of thing. You can draw that kind of outside red shape again, and it would be half. The triangles would be half of the whole thing, and so the area of this is going to be 1/2 d1 times d2. Okay, so whatever you see here on the white part definitely should be drawn. If you wanted to add this in extra, that's fine. If you wanted to add in extra stuff to help you remember more things off to the side, that is fine. Go back and rewind as needed to hear the explanation. I really want you to understand why something is what it is, why the formula is what it is. If you can remember why it is what it is, it's a lot easier to remember the formula in the first place. I don't really memorize these formulas. I think about them and they come to mind. They just are naturally there because I know where they come from. So let's do an example though. And let's see, there's some examples. This will all be kind of the same type of question. So find the area of these shapes. And so I think I'll use my shape tool. Why not? I'll use that to make these a little easier to deal with, or easier to tell what I'm doing. So let's say that one is going to be a triangle like that. We'll make this one a parallelogram. I'm going to make this one a trapezoid. And it's going to be almost but not quite an isosceles trapezoid. So something like that I'd say would be almost but not quite. And then this last one I'm going to make a kite. So I'm not measuring these, but I'm just trying as best I can with a freehand sketch or freehand drawing without measuring to label things, to draw the shapes as they should be. So let's say this one's a parallelogram. We'll add that stuff in. This one's a trapezoid, so we'll add in just one pair of parallel sides. This one's a kite, so we're going to do that. And now I will add in excuse me, now I will add in some other things into here, some drawings, or some numbers here into the picture. So this one's going to be 4.5 down here. This will be 5. You need the height straight up and down somewhere though, so I'm going to put that in right here. And I'm going to say that the straight up and down height with respect to this base is 4.5. Over here, I'm going to say the straight up and down height is 8. This one I'm going to, nope, I'm not going to put units with that one. I'm going to say the whole thing from here to here is 16. And then this right here is 10. So from here to here is 10. That's what that's saying. Over here I'm going to tell you the perpendicular height, the straight up and down height is 5 centimeters. This is going to be 7 centimeters here. This one's going to be 6 centimeters here. This whole thing will be 19 centimeters, that base, and this one will be 9 centimeters. And then finally, this will be 6, we'll go kilometers. This is a big old kite, 6 kilometers. This is 11 kilometers. And this distance from here to here is 15 kilometers. Okay, So I'm actually going to have a different set of instructions with this last one. We're going to see a slight variation on what we're doing here. But let's start off with this one. Your area formula for a triangle is, if you forgot, go back to here. Think about it from there. It's 1/2 base times height. So 1/2 BH. What's your base? Your base, are you going to use 5, 4.5, or 4? I would say we need to use the 4.5. And then my height is the perpendicular part to that base. This is the part of the triangle that I can look at. This is a possible base of the triangle, but with respect to that base of the triangle, this would be the height. This would be perpendicular to that part. It's 4, straight up and down. So you'd have a 4 in for your height there. You can do multiplication in any order if it's all multiplication. We can change the order. So I could take this times this first. Half of 4 is 2, and 2 times 4.5 is going to be 9. Since there are no units, you can leave them out. If you wanted to write in the word units, you would have to write units squared. If there's no units, you don't have to write them out. This one was a triangle. So first you're basically determining what kind of shape it is, and then you can plug in the numbers into the formula. You can use the formula to plug in those numbers. What kind of shape is this? This one is a parallelogram. So the formula for that, go back here if you forgot, parallelograms, that's base times height. So we're going to use BH because it's a parallelogram. And so from there, your base would be 16. We're talking about one of these sides. You could also use 10 as a base, but you'd have to have the perpendicular part to that as your height, which we don't have here. So I'm going to use the parts that are perpendicular to each other are 16 and 8. That's what I need to use. So my base would be 16. My height perpendicular to that base is 8. If you multiply 16 times 8, 8 times 8 is 64, so you can just double that, and you're going to get 128. So 128, there's no units, so you could be done right there. If you were to write the word units, I would need to see units squared and not just plain old units. This one, this is if you say trapezoid, you got it. It's one pair of parallel sides here and here. So go back here. This is our formula. It's the average of the bases. That's the 1/2 B1, B2 part times the height. And so let's use that formula. Let's write that down. 1/2 height times the average of the bases. We're doing that because it's a trapezoid. Okay, and here we have 1/2. What's your height? Straight up and down. We're not talking the height on these slant parts here, but straight up and down. With respect to the bases, what's the perpendicular part to the bases? It is 5. So this should be a 5. And then your B1 plus B2, you could say this is B1 or this is B1. It doesn't really matter what order you add them in. I'll go with 9 plus 19. Let's add these together first. PEMDAS, please excuse my dear Aunt Sally, we would do parentheses before we would multiply stuff. So we would have 1/2 times 5 times, this would be 28. And again, you could change the order now that you multiply things in, since that's all we have left. You could do half of 28 first. Half of 28 is 14. 14 times 5 is 90. So this would be, not 90. No. 14 times 5 is 70. Yes. There we go, is 70. So this would be 70, and that's a pathetic looking 70. Let's try that one more time. 70, that's better. And this would be, you have units given to you, so you got to include those. Centimeters, and it's an area, so centimeters squared. Area is units times units. Units squared, in other words. So this is centimeters squared. On this one, I was actually going to tell you that this was true. The area is 52.5 kilometers squared. So if I told you that was true, and I said find the length of D2, we'll put that as instructions here. So this one has a different thing we need to find. The area of these shapes, that went for these three. This one has the different instructions. What kind of shape is this, first of all? This is a kite. And so what do we use? What's the formula for that? They're triangles. There's 4 of them, so it's based on that half of a rectangle formula, but it's half of the diagonals. So it's 1/2 d1 times d2. Using that formula because we have a kite. So let's fill in what we know. We know d1, one of my diagonals, is 15. So I'm going to plug in 15 right there. My other diagonal, I don't know. I'm going to use that or write that as d2. So do we actually know A on this one? We sure do. We know the area. So we're told that. So in this one, this is where it gets a little different here. But we can plug in A. It's 52.5. That's what it has to be. And so I'll use parentheses there. I don't have to, but I'll use them because that was plugging in what A was there. So I usually use parentheses when I plug stuff in. Now what's 1/2 times 15? This is going to be 7.5 or 7.5. I'm going to use a decimal for that. 7.5 times d2. So 7.5 d2 would be 52.5. At this point, it's okay to divide by a decimal, so we're going to divide by 7.5 because we want d2 by itself. So if I do that, this goes away. 52.5 divided by 7.5. Ran out of space, so I'm going to say, finish that up over here. I still have d2 left. d2 equals, if you take this and divide it by this in a calculator, it ends up working very nicely as an exact number. 7 is the length of this second diagonal from here to here. Is that kilometers squared? No, this is now just a length. The length of the diagonal would be just plain old kilometers. And so we did not do a square or a rectangle because I'm hoping those are pretty good for you, hoping that those are pretty easy for you already. There was one other one. We didn't do a rhombus, but a rhombus is exactly like a kite. And so that should help you do both of those types. So we did, I think, 4 of the tougher ones here. Go back and review as needed. We'll check out a few more in class together. And hopefully you found that helpful and can just knock this assignment out of the park and do really well on area formulas on the test. Let me know if you have any questions in class, and I will catch you guys later.